Good morning, all. Are you able to hear?
Yes, sir.
Hello.
Yes, sir.
Okay. Good morning. Today,
Good morning, sir.
good morning, good morning. Today we will discuss the maths topic related to probability. Okay. Probability. So probability is our topic. First of all, we will discuss some terminology. Experiment. Experiment, we are doing something. We will get some output. That is an experiment. We are doing something, we are getting something as output. That is experiment. Now, in probability, we are dealing with random experiment. A random experiment. What is a random experiment? We know we are doing some task, or we are doing some experiment. So we already know what are the possible outputs, but we don't know what will be the exact output. That is known as a random experiment. For example, you are tossing a coin for a single time. So you will get head and tail. These are the possible outcomes. You know that. If you toss a coin, you will get head or tail. You know that. But you don't know which will be the output. If you are tossing a coin now, whether you will get head or tail, you don't know. Exact output, you don't know. But all outputs, you already well defined. So that such an experiment is known as a random experiment. All outputs are well defined, but exactly we don't know what will be the current output. That is random experiment. Random experiment are equally likely. The outcomes are equally likely. Equally likely outcomes. What is equally likely outcomes? There is no partiality towards any of the output. There is a more chance for head and less chance for tail, or more chance for tail and less chance for head. No, not like that. There is equal chance for both head and both tail. That is known as equally likely outcomes. So what is random experiment? Random experiment in experiment whose outputs is well defined. Before doing the experiment, outputs are well defined. But one thing, we don't know what will be the next output. Another one, for example, if you roll a die, you will get 6 outputs. 1, 2, 3, 4, 5, 6. These are the possible outputs. But what will be the next output? You don't know. What are the possible outputs? You know. So that is an example of a random experiment. So this is for the case of a die. A die is rolled. This is for a coin. A coin is tossed. Then, in the case of, so what is next terminology? Sample space. Sample space is normally represented by S. It is a set or a collection of all possible outputs. For example, if you toss a coin, you will get head and tail. These are the possible outputs. So this is the sample space. Another example, if you toss a coin for 2 times, so what is the output? Output can be head, 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 tail, tail, head, tail, tail. So here you got 4 outputs. So this is the sample space. So if you toss a coin, there are 2 possibilities. One is head and two. Another is tail. So 2 raised to 1 output will be there. That is 2. If you toss a coin for 2 times, there will be 2 raised to 2, 4 output. For example, this one. 2 raised to 2, 4 outputs. If you toss a coin for 3 times, there will be 2 raised to 3, 8 outputs. That sample space can be written like this. If you toss a coin for 3 times, head, 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 tail, head, tail, head, then tail, head, head, then head, tail, 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 head, tail, then tail, tail, head, then tail, tail, tail. So 1, 2, 3, 4, 5, 6, 7, 8. So for a single coin, you will be getting 2 outputs. If you toss the coin for 3 times, you will be getting 2 raised to 3, 8 outputs. If you throw the coin for n times, you will get 2 raised to n outputs. 2 raised to n outputs. In the case of die, if you roll a die, what is the possible outputs? 1, 2, 3, 4, 5, 6. There are 6 outputs. Means you are getting 6 outputs. You rolled the die for only single time. So output is 6 raised to 1, 6 outputs. If you roll the die for 2 times, you will get 6 raised to 2, 36 outputs. 36 outputs. So what is sample space? Sample size will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, like that. 3, 1, 2, 3, 6, 4, 1, 2, 4, 6, 5, 1, 2, 5, 6, 6, 1, 2, 6, 6. So here you are getting 6 output, 6 output, 6 output, 6 output, 6 output, 6 output. So 6 into 6, you are getting 36. That is equal to 6 raised to 2. So if you throw a die for 2 times, you will get 6 raised to 2. If you throw a die for 3 times, you should get 6 raised to 3. If you throw a die for n times, you should get 6 raised to n outputs. So in the case of a coin and in the case of a die, you will be able to calculate the number of outputs by this shortcut. Okay, so when you are doing a experiment, that experiment should be in random experiment. That random experiment, the collection of all possible outputs, that is known as S or sample space. What are the possible outputs you are collecting and kept inside a bracket? That is known as sample space. Then what is event? Event is actually a sample or sample of the sample space, or you can say that subset of a sample space. For example, S is equal to head, tail, head, tail, tail, head, tail, tail. This is a sample space. This is a sample space for a coin tossed for 2 times. A coin tossed for 2 times. So this can be represented, or we can take a simple example. For example, a coin is tossed for a single time. A coin is tossed for a single time. So you will get a head or a tail. So what are the subset? Subset can be written as a Kali one, nothing, and one is H, and another one is tail, and another one is HT. So these are the subset of sample space. We can call it as subset of sample space. This is empty one, this is complete one. This is empty, this is complete. But there are 1, 2, 3, 4. 4 subsets are there. 4 subsets are there. This subset is known as event. Subset is known as event. An event is defined by us only, but it will be always a subset of our sample space or sample space. When you are doing one problem, you will understand. For example, first question. You are tossing a coin for once. What is sample space? S is equal to head, tail. I am defining an event. What is event? Event is defined as getting a head. Event is defined as getting a head. So what is event? Event matlab head, only one possibility. Event equal to head. So in sample space, how many elements? In sample space, how many elements? N of S is equal to 2. In event, how many elements? N of E equal to 1. So what are the total outputs? Head and tail. So total number of possible output is 2. But event is defined as getting a head. Event is defined as getting a head. Means that is the favorable thing. Event is favorable for the user. So event is a favorable thing. So getting this output is known as favorable outcome. Favorable outcome. E equal to set of H is known as favorable outcome. So what is S? S can be represented as total possible outcomes. Total possible outcomes. So what is probability? Probability is actually the chance of getting an output or chance of occurrence of an event. Probability is the chance of occurrence of an event or chance of getting the favorable outcomes. That is known as probability of an event. That is known as probability of event. So what is probability of event? That is defined as probability of event is equal to, that is the definition, number of favorable outcome divided by number of total number of outcomes. Number of favorable outcomes divided by number of total number of outcomes. So in this case, number of favorable outcomes means number of elements in E. Total number of outcome means number of elements in the whole sample space. So in this particular case, number of elements in the event is 1 and total number of elements in the or the outcomes in the sample space is 2. Therefore, probability of the event is equal to 1 by 2. 1 by 2. That is probability of an event. Chance of occurrence of a favorable outcome or chance of occurrence of an event, that is known as probability of an event. That is the definition of probability, which is equal to number of favorable outcomes divided by total number of outcomes. Another example. Coin tossed for 2 times. So what is the sample space? Sample space is equal to head, 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 tail, tail, head, tail, tail. So what is the number of possible outcomes? Total number of outcomes is 4. So now we have to define an event. So event E. Event E. Event E. We can define. The user can define event E. Getting 2 heads. Event E is defined as getting 2 heads. We are tossing a coin for 2 times, getting 2 heads. So who are the members of the subset or the event E? Who will be the members? H. Getting 2 head means only one favorable outcomes. Only one favorable outcome. I want to get 2 heads. So I should get 2 heads. That means out of the sample space, the outcome favorable for me is only 1. So number of elements in the event is equal to 1. So what is the probability of the event? N of E by N of S equal to 1 out of 4. 1 out of 4. Another event. Another event we can define. Getting look this terminology. At least 1 head. At least meaning, what is the meaning at least? You should get at least 1 head. More than 1 chalega. There should be at least 1. Zyada hai to chalega. That is the meaning of at least 1. So what are the favorable outcomes? Head, tail. That is a favorable outcome because 1 head is there. Tail, head. That is also a favorable outcome. Then head. What is the question? Getting at least 1 head. If more than 1, no problem. But less than 1, not acceptable. So probability, therefore the number of elements in the event is 3. So probability of getting at least 1 head is 3 out of 4. Means number of elements, number of favorable outcomes divided by total number of outcomes. That is meaning of at least 1 head. Getting at least 1 head. And then another I will define. Event E. Here I am going to represent getting at most 1 head. See the difference between at least and at most. At most matlab meaning if you want to put only 1. Nahi to bhi chalega. If you want to put 1 head maximum. If head is not there, that is not a problem. So what is our sample's favorable outcome? Head, tail, only one head. Tail and head, only one head. Tail and tail. We cannot put HH because that is more than one. So in TT, there is no head because condition is at most one. If we want to put one. If you are not putting any head, no problem. So that is, these are the possible outcomes. So number of elements in E is actually 3. So probability of getting at most one head is equal to n of E by n of S, that is 3 by 4. So at least one head, at most one head, getting two head. Then if getting one head, if event is defined as getting one head, then even we will be getting HT and TH because clearly told that getting one head. So number of elements in E will become 2 and probability will become 2 by 4, that is 1 by 2 because clearly told only one head. Then another event you can define getting. So one head, two head, at least one head, at most one head, getting 0 heads. Getting 0 heads. If you are tossing a coin and getting 0 heads means what is the event? Event is equal to 0 head means only one possibility, TT. Both are tail. That is the meaning of 0 head. So probability will become 1 out of 4. So this is the definition of event. So probability of an event is equal to number of favorable outcomes divided by number of or total number of outcomes of the experiment. That is known as probability of an event. So sample space is the total output. And the subset, a sample of sample space is represented as an event or subset of sample space is represented as an event. So probability of an event is equal to number of favorable outcome divided by total number of possible outcomes, n of E by n of S. This is the basic rule of probability. We are calculating the chance of occurrence of an event. So this is the example of a coin. Now we will do example of a die. Die rolled once. Die rolled once. So what is the sample space? 1, 2, 3, 4, 5, 6. These are the sample space. Here so many events we can define. E, getting a prime number. Getting a prime number. What is prime number? 2, 3, 5 are prime number. 1 is not a prime number. Here prime number is 2, 3, 5. So what is E? E will be 2, 3, 5. So number of elements in the sample space is 6 and number of elements in the event is 3. So the probability of getting a prime number is 3 out of 6. That is 1 by 2. 1 by 2. Another event. Getting an odd number. So what is the elements of this event? Odd number means 1, 3, 5. They are the odd numbers. So number of elements in event kya hai? 3. So probability of event will be equal to 3 out of 6. That is 1 by 2. Another one. Similarly, getting an odd number, getting an even number you can do. That is 2, 4, 6. 2, 4, 6 means that is also 3. That probability of getting an odd even number will become the same thing, 3 out of 6. Then getting event is defined as getting a multiple of 3. Getting a multiple of 3 means we know that 3 is a multiple of 3 and 6 is a multiple of 3. Therefore, probability of getting a multiple of 3 is actually n of e by n of, what is n of e? 2. So 2 out of 6. 2 out of 6 because here only 2. So 2 elements are there. Therefore, 2 out of 6. This will become 1 by 3. That is a getting a multiple of 3. Another one. Another one we can define. Getting a multiple 5. Getting a multiple of 5. From the sample space, we are getting only 5 as the multiple of 5. So the even will be equal to 5. So number of elements is n of e is only equal to 1. So probability of getting a multiple of 5 is equal to 1 by 6. 1 out of 6. So when you are rolling a die for a single time, probability of getting a multiple of 5 is 1 by 6 because 5 is the only number. In this way, probability of getting 1, probability of getting a 2, probability of getting 3, probability of getting 4. Probability of getting 4, what is it? Probability of getting 4? 4, probably if you write like this, probably getting a number 4. So even is actually equal to 4. So probability of even will become number of elements in E divided by number of elements in the sample space. E is only 1 and 1 out of 6. So like that, probability of getting a different numbers, probability of getting a prime number, probability of getting a even number, probability of getting odd number, probability of getting a multiple of 2, probability of getting a multiple of 3, probability of getting a multiple of 5, like that, different varieties they can ask question. Then we will consider another question. A die. A die is rolled for twice or 2 dice are rolled for a single time. Both are correct. A single die rolled for 2 times, same as 2 die rolled for a single time. So here a die rolled for 2 times. 2 times. So what is the sample space? You can write like this: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Like that, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are the sample space. These are the possible outcomes. When you roll a die for 2 times, when you are rolling a single die for 2 times, you will get 6 raised to 2, 36 outputs. Here, this is the sample space. Here we can define so many events. Getting both numbers prime, getting the sum is equal to 6, getting both number a multiple of 3, getting both number same, like that, different events we can defined in this sample space. For example, I will do 1 or 2. E. Event E is defined as getting a sum equal to 6. So what are the events? 6 means 1, 5. 1, 5, 1 plus 5, 6. 2, 4. 2, 4. Then 3, 3. Then 4, 2. Then 5, 1. These are the possible outputs, favorable output. Getting a, what is the event? Getting a sum equal to 6. So in our event, how many members? Number of elements in the event is equal to 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 1, 2, 3, 1, 2, 3, 4, 5, 5. Number of favorable outcome is 5. Number of favorable outcome is 5. So what is the probability? Probability of the event is number of favorable outcomes divided by total number of possible outcomes. So it will become 5 out of 36. Another one I will do. An event E defined as getting. What we have to write? Getting both are prime. Getting both are prime. Getting both are prime. So what is E? Both are prime means one is not a prime. Please see, one is not a prime. So we cannot take anything from here. We cannot take anything from here. One is not a prime. 4 is not a prime. 6 is not a prime. So we can take only from 2, 3, 4. 2, 3, 5. So 2, 3, 2, 5. Then 3, 2, 3, 3, 3, 5, 5, 2, 5, 3, 5, 5. So these are the possible outcomes of the event. 2, 3, 2, 2 is also an output. 2, 2, 2, 3, 2, 5, 3, 2, 3, 3, 3, 5, 5, 2, 5, 3, 5, 5. So how many? Here you are getting 3, here you are getting 3, here you are getting 3. So total condition, what is the event? Getting both are prime. Getting both are prime means the number of elements in our event will be 2, 2, 2, 3, 2, 5. Like that. 3, 2, 3, 3, 3, 5. 5, 2, 5, 3, 5, 5. So we are getting 9 favorable outcomes. 9 favorable outcomes. So number of elements in E is equal to 9 out of 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of favorable outcome is 9. And the total number of possible outcome is 36. So 9 by 36, it can be written as 1 by 4. So probability of getting both the numbers are prime. If a die is rolled for 2 times is given by the value 1 by 4. So in this fashion, we can define so many events. Whatever the things you are defining, it will be every member will be a member of the sample space. Then we have to discuss the card case also, but since time is not there, we will discuss the card on next day. Before that, we will give you some basic idea. So probability of event is equal to number of favorable outcomes divided by total number of possible outcomes. A die is rolled. You are getting a sample space 1, 2, 3, 4, 5, 6. So here an event is defined. Getting a number equal to 0. My event is getting a number equal to 0. My event is getting a number equal to 0. How many members are there in the event? Nobody is there. We are getting a Kali set, empty set. So number of, because if you roll a die, you will not get 0 because the possible numbers are 1, 2, 3, 4, 5, 6. So you will not get any 0. So number of elements in the event is actually equal to 0 because we are getting a Kali, empty set. We are getting a empty set. Nothing is there. So number of elements in the nothing, empty set is actually equal to 0. So therefore, probability of the event is equal to number of elements in the event divided by number of elements in the sample space. 0 out of 6 equal to 0. Because if you roll a die, possibility of getting 0 is impossible, because in a die only numbers are written is 1, 2, 3, 4, 5, 6. Then how to get a 0? That is impossible. So we can say this event is a impossible event. We can say that this event is a impossible event. So for an impossible event, the probability value is 0. That is very important. For an impossible event, probability of the event will be equal to 0. Then another event is defined as getting a number greater than 0 and less than 7. Event is defined as getting a number greater than 0 and less than 7. So whatever be the output, if you are rolling a die, all possible outcomes are between 0 and 7. There is nothing to exclude. We should include all the things. So what are the favorable outcomes? Because the all possible outcomes are greater than 0 and less than 7. So number of members of favorable outcomes kya aega? 1, 2, 3, 4, 5, 6. That means all members of the sample space came into event also. All possible outcomes of sample space came to event also. That means we can say that this event is actually equal to sample size itself. This event is actually equal to sample space itself. So number of elements in E is actually equal to 6. So probability of event can be defined as number of elements in E divided by number of elements in the sample space, that is equal to 6 out of 6, which is equal to 1. So if you roll a die, you will get a number 100%. It is correct. You will get a number between 0 and 7, because only outcomes are 1, 2, 3, 4, 5, 6. You will be getting any of the number. So if a person is asking, we should get a number between 7 and greater than 0, means anyway we will get all possible outcomes. So this is known as 1. So we can say that this is a sure event. Anyway it will happen. No chance to exclude anything, because everything will happen. So this is a sure event. So what is a sure event? Sure event probability is always equal to 1. So we discussed the two things. Impossible event means that event is not at all possible. Then what is the probability? Probability will be 0. Is sure event means 100% pakka it will happen. That is known as sure event, or we can say that it is a certain event. Sure event or certain event. The probability of sure event is 1 and probability of impossible event is 0. So what is the range of probability? The value of probability can go up to 1 and 0. So this is the range of value of probability. So probability will be always between 0 and 1. It is always between 0 and 1. So this is the basic idea of probability. So we discussed conditions of coin and die. Now we require to discuss the probability related to our playing card. So that we will discuss on coming days. Okay, in this session, any doubt you can ask. Any doubt? Hello,
No.
कुछ doubt है?
No, sir.
No,
Okay,
sir.
then we will see tomorrow. Okay, thank you.
Thank you, sir.